We recently took a tour of the CeramicSpeed factory here in Denmark, but it may have left you with a few questions, maybe why you'd want to invest in their product in the first place. In a nutshell, the answer is on this wall. This wheel has CeramicSpeed bearings inside, and this one doesn't. But in this video, we are going far more in depth. We're going to look at exactly what CeramicSpeed bearings are, what difference they can make statistically through the testing procedures they have here. And I'm also going to be having a go at making a CeramicSpeed bearing myself. I'd like to start by telling you exactly how a ceramic ball is made. You start with a material called silicon nitride, which is then in powder form pressed into a pre-formed shape. That then is sintered, which is a hot isostatic pressing, after which any surface imperfections are removed with a grinding process. Then they use lapping and precision finishing to make sure that it meets the specifications of sphericity, diameter, and surface smoothness. And the result is that a ceramic ball like this is 400% smoother, 128% harder, and also 58% lighter than its steel counterpart. What that means is that when these ceramic balls are used in the bearings on your bike, it will significantly reduce the overall friction of the components, but also significantly increase their lifespan. Quite interestingly, the first ceramic ball was produced all the way back in 1972, but they weren't really mass produced until around 1990, and that is down to the quite staggering manufacturing costs of ceramic balls. These things really aren't cheap to make. I should also mention actually that not all ceramic balls are the same. I've said it in our factory tour previously, but CeramicSpeed balls are grade 3 specification, which means that they are round down to 0.08 of a micrometer, which basically is about as round as it gets. And it also means though that the production time for these are quite long, anything from 50 to 70 days. You can reduce that production time, but then they wouldn't be the same quality. But some other manufacturers do use a lower grade. But when tested, these grade 3 balls are shown to be 100% smoother and also withstand loads of 99% more than some of their competition. And in fact, I think we've got a test to show exactly that coming up a little bit later. Firstly though, let's go and have a look at exactly how the balls are used in the bearings, which are made by hand just around the corner.
Welcome to our OEM production site. That's where we will build our bearings.
Yeah.
All of them, of course, by hand. And you're gonna now see how we do it.
Okay, let's go.
First step of course, it's really important that these, when we have them, are coming as outer and inner ring. They always go together.
Okay.
So, second step would then be to add the right amount of ceramic balls. Different sizes of bearings uses different sizes and different amounts of balls, of course. So now the balls are sealed or secured inside the two raceways.
The next part of the process then is to make sure that the ball bearings are evenly distributed around. They have got a machine that does that, but understandably they want to keep it a trade secret. So I think I'm going to be doing it by hand.
Yes, yes, you are.
Hopefully whoever's getting my bearings that I'm building has got quite low tolerance in mind today.
We will help you.
Right, okay, what's the next step?
So next step from here would be those bearings which are produced. These will now be washed and cleaned. Since this is steel we are working with, of course all our operators are working with gloves. After the washing we still have gloves on and we have a protection film around the steel.
Okay.
Then we would have them dried and we would have them filled with grease. We can see that over here.
Yes, take a look.
This is a 50% filling. It's a very small, tiny, so to speak, grease source you put on top, and then you squeeze in the seal. So to make sure that we have an equal spread grease inside the bearing all around, we would use this machine.
Okay. And then the final part of the process is, well, more quality control, really, human quality control.
Yes, as you can see, the operator here is finalizing, so if there's air in the grease, you would be able to feel it, that it doesn't run.
Would I be able to feel it, or is it?
I don't think so. No, you will not. You will not be able to feel it.
Right, so now we have a machine that is measuring the play on all of these bearings, 3 times on each one, by the looks of it.
Yes, that's right. So we took some bearings away. And this order, there is every fifth part we'll take away for extra measuring. And that is that machine that will measure the play. And as you just said, we'll measure each bearing 3 times here as well.
Yeah.
And this is a document for us, and this is a document for the customer that we are inside that tolerance.
Oh, so you send this out with the bearings to the customers so they know exactly the tolerances of every bearing?
That's right.
Wow. Right, it's the moment that I have been waiting for at least. I've got my box of parts. I've got my name on the box. Do I need I've got gloves.
You've got gloves.
I've got gloves.
First of all, I would put the inner raceway in the outer, yes. And to give you a little helping hand, we prepared this little piece for you, a smiley. Now you place the outer ring around the smiley and the inner ring on the inside again.
Okay.
Exactly. You're getting good at this, Dan.
Oh, steady hand, you see.
Oh. Next step for you is to press the inner ring against the outer ring until it says click.
I don't want to break a nail.
There was the click. Now you take one or at least one of the balls and squeeze it to the other side. That's good. So now you separate the balls with equal distance.
Almost there.
Very well. Really nice. You can turn the bearing around because you would have the branding.
Oh no!
There's
They've all moved round.
Oh, shame.
To redistribute them.
Very well. So you can take the bearing now, lift it on top of the...
Oh, I see, okay.
You should now be able to press. There we go. You can place this tool inside the middle as well. Yeah, exactly.
Oh, there we go.
Perfect.
So, time to clean it up. Drop it in degreaser. And it's just like a protein shaker.
That's good. I'll switch on the extractor in a moment. I'll ask you please to wear ear protection and glasses.
Going in. That's brilliant. Right, guarding this with my life. So, time for the seals.
Then you press it slightly from the outside, very gentle. Yes. And make sure that it's all covered. Now you can hold the inner ring, the outer ring, and then you should be able to turn it and it feels free. And it actually does very well. What you do is you give it one drop.
For each bearing?
No, just you can put one on each side, so like one drop there. Exactly.
Time now to put some glue on the inside of the pulley wheel here. Ready for the bearing to go in. You only need a very small amount.
Correct.
There we go.
Please take the cloth. Make sure that over the glue that's been pressed outside on the back side maybe.
Oh yeah.
Yeah, has been removed. Now you can do the check one more time in your tool.
That's beautiful, isn't it? It's like the car wheels in the movies.
Yeah.
So we are now ready to put the whole lot together, the pulley wheels inside the cage. Remembering, because they very kindly put my name and GCN on this pulley wheel, which is quite frankly amazing. So remember to put that on the outside so anyone that takes a close look can see it's custom.
There we go.
Voila. How's that?
It takes a little bit longer than it would be standard-wise.
My first go.
Yeah, really good.
Yeah, I'm happy with that.
I would still say there is just a slightly thing we still need to do. We need to put it in the right box.
There we go. Now we're in. And then normally, I'd put that 4-year warranty sticker in there as well, but not sure I'm confident enough, having built it myself, to do that. So I'm going to send that to myself and do my own little unboxing at home. We've come to do quite a simple test called the hammer test. We're literally going to drop a metal hammer onto a metal block and on it will be a ball. One of the balls will be from CeramicSpeed, another from a different manufacturer, both ceramic though. Should we give it a go?
I think so, yes, let's do it. So I placed the ball. I'll just adjust the hammer.
Wait a minute, which one is this one?
I'll show you.
Is that yours?
It wasn't.
I'm joking.
It was not mine, no.
Right, so that one's shattered.
Yes, all over the place actually. I will now place another one, ours.
Okay, ready? Yeah, it's all in one piece. So I guess that shows that there are different grades even within ceramic bearings. But as probably a lot of people would ask you, we don't generally take a hammer to the bearings on our bike. So why does it need to be like that, or how is it better?
So the quality of the ceramic balls itself in the hubs, in the wheel bearings, will show that you will have a lot of impact from the road going onto the bike. It will not be as one impact, but it will be smaller impacts all the time. And if there is a lack of quality, the balls will be destroyed. They will not explode like this in your bottom bracket or in your wheels, but they will over time start to break down.
Let's get down to the nitty-gritty. How much are you really going to save energy-wise by using these products? Well, let's break it down and start with the bottom bracket. There, at 250 watts, you can expect to see a saving of between 1 and 3 watts, and it's likely to be around the same for the hub bearings as well. And then we have the oversized rear pulley system here. That will save you 40 to 60% of frictional losses compared to a normal rear derailleur. And I should also mention that these comparisons are all against very high-end products as well. And then when we get onto the UFO treated chain, again, depending on the manufacturer, that will save you anywhere between 3 and 5 watts. And when added up all together, that really is quite a significant saving. Whether or not they are for you, well, only you can answer that question. But if you are slightly obsessive, a little bit like the founder Jakob here, and you want to eke out every single drop of performance from your bike, then I think I can guess what the answer will be. And it's not just that energy saving. We've already mentioned the fact that the other thing about ceramic bearings is their longevity and durability. And I'm going to give you a couple of examples of that now. CeramicSpeed officially supply 3 World Tour squads in 2018 and unofficially a whole host more. And many of them are using their bottom bracket bearings and their hub bearings for the 3rd season in a row. They simply transfer them and move them onto the new bikes for the new season. And given the extreme testing ground that is pro racing, that is quite impressive. And then the second example, you may remember from our factory tour, their drum, which they used to test the wheel bearings on. And one of the tests that they did on that drum was to use completely dry bearings with only 1 single drop of very thin oil. Standard steel bearings, well, that wheel lasted for 5,000 kilometers before it failed, but with the ceramic bearings, they lasted 45,000 kilometers before the rim failed. All quite interesting stuff. They certainly don't come cheap, but then again, you're probably not going to have to replace them very much, if ever. Well, I hope you have learnt as much as I have from my experience here in Denmark. I've very much enjoyed being here at CeramicSpeed. If you missed the first factory tour, you can find that by clicking just over there. And if you've enjoyed this video, please give us a thumbs up just down below.